Good morning, students. Today we are going to discuss electrostatic potential. Now, what is electrostatic potential? The electrostatic potential at any point in the electric field may be defined as the work done by an external agency in bringing an unit positive charge from infinite to that point. Now, if the work done is W in bringing the test charge plus Q0 from infinite to a point in the electric field, then the electrostatic potential at that point will be V is equal to W by Q0. Therefore, W or the work done will be V into Q0. Next, let us define the potential difference between 2 points. The potential difference between 2 points, say A and B, in the electric field can be defined as the work done required to bring an unit positive charge from a point A to a point B. Next, if the work done required to bring the charge plus Q0 from point A to point B in the electric field that is WAB, then the potential difference between the 2 points will be VB minus VA is equal to WAB by Q0. Next, if WAB is positive, then VB is greater than VA. If WAB is negative, then VB is less than VA. And if WAB is equal to 0, then VB is equal to VA. Now, electrostatic potential due to a point charge. Let us consider a point charge plus Q. Suppose the point charge is situated here and its electric field will be surrounding it. And if we want to bring an unit positive charge from infinite to any point, suppose this point, say P, inside the electric field of the point charge plus Q, then we have to perform some work against the electrostatic field of this positive charge plus Q, because this positive charge will repel the unit positive charge plus 1. So, if we want to bring this positive charge, unit positive charge, from infinite to this point, suppose P, which is situated, suppose a distance R from the point charge plus Q, then what will be the work done? The electric field due to this charge plus Q is E is equal to Q by 4 pi epsilon 0 R square. Now let us draw this in a simpler form. Here the charge plus Q, and we want to derive the potential at this point P at a distance R, and the unit positive charge is at infinite distance. Now we want to bring this to this point. Suppose there are another point, say P1, which is at a distance dr from point P. Therefore, the distance of P1 is R plus dr. The distance is R plus dr. Now, the potential at point P will be the work done required to bring the unit positive charge from infinite to the point P. Therefore, we can write the potential at point P is equal to V is equal to 1 by 4 pi epsilon 0 integration infinite to R q by R square dr. Since this work is done against the electric field, so we can write here the negative sign. Therefore, if we calculate this integration, then the integration will be minus q by 4 pi epsilon 0 minus 1 by r from infinite to r. Finally, q by 4 pi epsilon 0 r. Therefore, the electrostatic potential at point P is q by 4 pi epsilon 0 r. Now, let us calculate the potential difference between 2 points in the electric field. Of a point charge. Suppose there is the point charge plus q and its electric field is surrounding it, and there are 2 points. Suppose this is point A and this is point B within the electric field. If we want to bring a unit positive charge plus 1 from A to point B, then the potential difference between the 2 points A and B can be calculated in this method. Suppose the coordinate of point A is R1. To explain this, we need some coordinate system. Suppose in Cartesian coordinate system, this is x, y and z, and this positive charge plus q is situated here, and for this the electric field is surrounding the positive charge plus q. Suppose the point A is here and the point B is situated here. You can write this is the origin, the coordinate of point A is R1 and this is R2, and OA is equal to R1 and OB is equal to R2. Now we want to bring a unit positive charge from point B to point A. Therefore, VA minus VB is equal to integration E dot dr, where E is the electric field of this positive charge plus q, and the limit will be R2 to R1 is equal to the electric field here, E of this charge is Q by 4 pi epsilon 0 R square dot dr integration R2 to R1. Now look at here, this is a positive charge Q and this is also a positive charge, though it is unit positive charge, but this is a positive charge, so this will repel the unit positive charge. So we have to write here the negative sign, because the repulsive force acting on the unit positive charge, and we have to do some work against the electric field to bring the positive charge, unit positive charge, from B to point A. So we have to write here the negative sign. Now if we integrate this, it will be minus Q by 4 pi epsilon 0. We can bring the constant term outside the integration, and R2 to R1 dr by R square is equal to minus Q by 4 pi epsilon 0 minus 1 by R R2 to R1 is equal to Q by 4 pi epsilon 0. If we take the negative sign outside, then it will be 1 by R1 minus 1 by R2, and finally this will be the potential difference between these 2 points. Now, relation between electric field and electric potential. Let us consider 2 points within an electric field. Both are situated very close to each other. This is suppose point A and this is suppose point B, and the separation between them is just dx. Thus point A and point B are very close to each other. Suppose the potential of point A is V and the potential of point B is V plus dV. If we want to bring a unit positive charge from point A to point B, if we want to bring a unit positive charge from point A to point B, then the work done will be E dot dx, where E is the electric field and dx the distance between these 2 points, and this will be the potential difference between these 2 points, point A and point B, that is V plus dV minus V, and the work done will be negative, since we want to bring the unit positive charge from A to point B. Therefore, if we simplify this part, it will be only dv. Therefore, minus E dot dx is equal to dv. Therefore, E is equal to minus dv dx. This is the relation between the electric field and electric potential.